Hello everyone, welcome back. We're continuing lesson number 4 and we have done the two P's, we've done the power rule and the product rule, and so in this video we're going to talk about the quotient rule and the chain rule. Two very important derivative rules that you will be learning. I think the chain rule will be the one that we use. Actually, I know the chain rule will be the one that we use the most. So let's go ahead and get into the quotient rule. I do want to summarize at the very end of this video the 4 rules again, just so you guys can see them collectively together. For the quotient rule, you have two functions that are actually being divided, hence the word quotient. So you're going to have y is equal to f of x all over g of x, okay? G of x. And so that's a weird looking y. Anyways, so f of x over g of x. So the quotient rule is this. So this, again, is a nice little way for it, but I'm going to show you guys, and this is exactly what I'm going to do here. But in this case right here, for the quotient rule to exist, order does matter. So for the product rule, remember, it was first times the derivative of the second plus the second times the derivative of the first, or you could flip-flop it and do the second times the derivative of the first plus the first times the derivative of the second. It doesn't matter the order as long as you find the derivative of one. Let me actually go right here and show you. So when you guys look, there's two terms here, right? You took the derivative of g in this one. You took the derivative of f in this one. It doesn't matter what order because we're adding things together. A plus b is the same thing as b plus a. So the product rule, we can do it in any order as long as you find the derivative of only one here and the other one here. Don't find both derivatives here and then do nothing there, right? So you got to find the derivative at least in one term. In this particular rule, this order does matter. You have to do it in this order. So we're going to start with the denominator. Okay, we're going to start with the denominator. You're just going to plot whatever the denominator is right here, and then you're going to multiply by the derivative of our numerator. Now, I always tell students that this is a quotient rule because the order matters and you can't mess it up. It's much worse than the product rule, so we always do a negative, right? It's going to be a negative for this. So it's the denominator times the derivative of the numerator. And then this one, well, what we haven't done, so now it's the numerator times the derivative of your denominator. So the derivative of your denominator has to be second. It's got to be the last thing that you do. And then we have our nice little line. And then we have, because it's a quotient, we need a quotient as our derivative. And so you're going to take our denominator and we're going to square it. Okay? So there's a little sign, a little song for this. This is the high, and this is the low, right? This is the high function, this low function. So it's low d high minus high d low over low low. And so I tell students that you have the minus here, and if you do listen to it again, so it's low d high minus high d low. Heidi, the name Heidi's in here, right? So minus Heidi. All right, Heidi low, that's her name. Heidi low minus Heidi low over low low, right? Low low. So two lows in the bottom. So low d high, low, and then d high. And so these are the song that you can actually sing here. So low d high, and then our girl Heidi low, right? Minus Heidi low over low low, right? So maybe we break up with Heidi low, and then she's low low. She's sad. I don't know. You guys will learn it. You're intelligent people. So let's just go ahead and show you the example for what we're doing here. Okay, so in this function right here, this is going to be obviously our top function, so we just call it f of x, and this is going to be our bottom function, g of x. One of the things I just want to tell you guys really quickly that we do in AB that's quite important is if I gave you guys this function right here, and I made this over, let's just say x, right, over x, and we've actually talked about this in the previous video in this class, but if you do this, you can actually split this up. You can split up the numerator and make this y equals x plus 1 minus 2x to the negative 1. And then, my goodness, how easy is it to do with that derivative that way? So if you're given a quotient, don't always assume you have to use the quotient rule, especially if there's polynomials here, right? So in this particular case, this one you will have to do, but I'm just saying that just for the side notes that, sometimes if you just got a singleton in the denominator, you split that thing up, right? Split that thing up. Okay, but back to this problem right here. So we're going to find the derivative of this function, so f prime, and I want to say very quickly that these are the same notation. So f prime and f prime of x. Some students be like, why are we doing this? There's so many different ways of doing notation, like this is also another derivative. D over dx of our function is the same thing. So let's go ahead and use the quotient rule for this, and it's pretty easy. So we're going to do low, right? Low, which is x cubed plus 6. And then we're going to multiply by d high, the derivative of high. So we're going to find the derivative of this, which is going to be 2x plus 1. All right, again, power rule. I'm using the power rule here. Minus, and now we got a girl, right? Heidi low. So high, Heidi, and then d low. So the derivative of our denominator, the derivative of our low, which is going to be 3x squared, again, using the power rule. And then we're going to just do low, low. So low, you're just taking your function and you're squared it. You do not have to simplify this. You don't have to FOIL it out and just leave it as it is. We're going to leave the problem here because this is as good as it's going to get. Yeah, you can simplify it more by distributing this, and then simplifying terms. But right now, again, we're just showing you how to use the quotient rule. So let's show you guys one more example for this quotient rule. Actually, there's two. Didn't see it. So for question number 4, it says h of x equals the square root of x over g of x. So sometimes they may not even give you a function. They may just tell you that this is just g of x. And it's asking you guys to find h prime of 4 when they give you these two values. Sometimes this is in table form as well. So what I always tell students to do is first of all write out what the derivative is. And so we can do, h prime of x. So we're just going to find out what this derivative is first before we even worry about plugging in the values for it. So again, it's going to be low. So it's always your denominator. All right, and then we're going to find the derivative of your numerator. So this is one of the two I told you guys that it's really, really, really helpful to just know what this derivative is. And I will tell you guys that it just saves a little bit of time when you guys are taking calculus exams. When you're on the AB exam or the BC exam, it's really important that you can do as much as you can without doing a lot of thinking. And so knowing that derivative is 1 over 2 square root of x is pretty awesome. Minus. And so then we're going to do the top. So here's our high, d low, high, and then d low. So it's just g prime of x, and that's okay. Just write it like this. You can put parentheses around it if you want to. I'm okay with that. Let's put parentheses around this. All right, and then all over low, low. And I like to put it in terms of this. So that's the first part of what we're going to do. And now we simply just have to plug in 4. Well, the first part here is g of 4. Well, g of 4 is given to us, it's just 2, right? So this would be g of 4 is our first thing. So if we're putting in 4 now, so that would be 2. We're going to plug in 4 here. Well, the square root of 4 is 2. 1 over 2 times 2 is 1/4. We're going to minus. We're going to plug in 4 here. The square root of 4 is just 2. We're going to find g prime of 4, right? So g prime of 4 goes in right here. We're given to us that that's 3. And it's all over, again, g of 4, right? G of 4, and then we want to square that number. So g of 4 is 2, and we're going to square it, and we're going to get 4. Normally, we don't like fractions inside of fractions, so you do need to simplify this a little bit more. So if you take 1/4 and you multiply that by 2, then you're going to get 1/2. And then you're going to get minus 6 over 4. And then we're going to do our simplifying to get negative 11/8. Okay, so this is the answer to this problem. All right, so question number 5 is just kind of summarizing everything we have for the problem. Students look at this problem and say, okay, and this is, I get this every single year, Mr. Walters, what if we take this and do that to it? And then find the derivative using the power rule. Well, technically, from what you've learned right now, that's not right. The reason you can't use the power rule here, you have to use the chain rule, which we're going to get to here in a second. So right now, I'm going to say, put a pen in this for a moment. When we're going to do this using the quotient rule, because it's in the quotient rule thing. And then if you want to come back to it, once I show you guys the chain rule and you want to do the derivative of this, then you're more power to you. I'm personally not a big fan of negative exponents but you know, to each their own to whatever we're going to decide to do here. But let's just see what we can do with this. So it says find the equation of the tangent line of the curve at the point -1, 1. -1, -1. So we automatically know that our equation of our tangent line is going to be, and I'm going to just do it. I shouldn't do it because it's BC calculus, but you know, if you don't know the equation of a line in point slope form, there it is. Everything that you do for this class, you can leave it in point slope. Do not slope intercept standard form. Who cares? We're good to go with this. So in this particular example, we already know everything. We're given the point, right? So y plus 1, x plus 1. So all we need to do is find the slope. So it's really asking us to find f prime of -1, right? Because that's what the x value is. So that's what we're doing. So we're going to find the derivative of a function, and we're going to plug in -1, and whatever we get, we're going to put in this line right here. So let's now do that. So y prime is equal to, well, our denominator, so good old low, minus the derivative of high. Well, this is a constant, so that just goes away. So it's 0, right? Derivative of a constant 0, minus our girl Heidi. So high times the derivative of our denominator, and then all over our denominator squared. All of that squared. And so we don't need to simplify. That's another thing that I really want to stress with you guys, is we don't need to simplify. You just want to plug in now. That's also a waste of time. We can immediately eliminate that. We know that that's going to just be 0. So we're going to be left with -1 times, well, we're going to plug in -1 here. So -1 squared is +1. So it's just 6 minus 1, which is 5. So that's all of it. And see how awesome is it that I did that and not have to worry about simplifying these things. And then down here, I know that this is going to be -1 cubed is still -1, so that's going to be -2 minus, well, -1, right? -1, and that's going to be plus or positive. And then we're going to square this whole thing, and I'm going to get -5 in the top. I'm going to get -2 plus 1 is -1. -1 squared is 1. So I'm going to get that the slope of this tangent of this line at -1 is going to be -5. So all I have to do now, since I know it's -5, is plug into our equation, and we are good to go. And I want to just summarize the 3 that we've learned, and then I'm going to do another video. For the third video will be on the chain rule. Okay, so let's go ahead and do another page for a second. So let's just say what we've summarized right now. So in order for us to use the power rule, our function is going to be some constant c x to the n. All right. So I'm not a big fan of notation as far as this is concerned. I want you to know that the derivative is going to be the product of these two numbers, and I'm going to give you guys an example in a second. So we're going to multiply c times n. We're going to leave our function alone, and we're going to subtract 1 from it. So an example of this would be f of x would be equal to 9x to, that's to the 3/2 power. I don't know why I chose horrible numbers, but it's okay. The 9x to 3/2 power. So then the derivative of this would be 3/2 times 9, which is just 27/2, and then x to the 1 less power. And that's it. So multiply this times this, and then subtract 1 from the power. So that's our awesome power rule. Product rule. The product rule, you'll be giving two functions that are being multiplied together. And so this is just simply going to be, so y prime is going to be equal to the first times the derivative of the second plus the second times the derivative of the first. Okay, and then simplify if you need to. Ladies and gentlemen, if it's FRQ, you can leave it alone. If it's multiple choice, then just obviously see what your answer that you have right here and just compare it to the 4 answers that is left. And then our friend, the quotient rule. All right, and we're going to finish up our video just by that. So in this one, we have y is equal to f of x over g of x. And so our derivative for this is going to be the denominator, or our low, All right, and then we're going to find the derivative of our numerator. So low d high minus, so remember minus here plus here. So minus our girl Heidi, right? High. Then d low, derivative of low. I don't know if this is the first time I told you guys that D stood for derivative. I think I kept talking about this song. And so I apologize that, yeah, D is derivative. So low D high, derivative of high, minus high D low over low low. I get so excited about this song that, yeah, times low low. And so those are the 3 of 4 derivative rules that you should now use and be okay with. All right, guys, so let's go ahead and do 3 more examples, just some random questions with derivatives and some strategies that I want to kind of throw at you guys for these 3 questions. So we're going to do questions 6, 7, and 8 that's in your note packet. First of all, if you look at example number 6, you see this, and we've actually already had this conversation where you're thinking, okay, let's do the quotient rule. Well, how gross does this look if you do the quotient rule? So if you look at my answer key, online, you guys will see that I did the quotient rule first, and then I wrote yuck because it's absolutely horrible, because there's a much nicer way of doing this by simply rewriting. We can rewrite this first before we actually do other stuff. So I can split this up, and because this is a video, I know that I'm being really silly with this, but you know, whatever. I'm just going to show you guys. We can absolutely split this rational function up into these little pieces right here. So if we do this, and again, notice my notation, I'm still not finding derivatives yet. F of x is equal to, well, this is just going to be 3x. Awesome. And then this is going to be 2, and so it's going to be x to the negative 1/2. Right? So there's our function. And I'm going to leave it in negative because I'm going to find the derivative using the power rule. So instead of doing this crazy quotient rule problem, I can now do the power rule. I just also want to say that we haven't seen this quite yet, that notice that this says the derivative, that's what d over dx is, of f of x. So you guys have seen find y prime, or find f prime of x, or h prime of x. But you can also see d over dx of f of x. That's the same thing. Or you can also see dy over dx. And that's also a derivative notation. All these are derivative notations. So when we're doing this problem, we're going to actually solve this derivative, right? So this is just equal to the derivative of f of x. So they're the same thing. And we're just finding the derivative. Well, the derivative of 3x is just 3. Again, using the power rule. The derivative of this, we're going to move the negative 1/2 down, and we're going to get negative 1. We're going to get x to the 1 less power. And so we're going to get that this is going to be 3 minus 1 over x to the 3/2 power. And there you go. There's our answer. You don't have to combine fractions. We're good. We're good. We're good. We're good. So the highlight of number 6, why it's in your notes and why I'm showing you guys this in your video, is that if you are given a function, a rational function, and you can easily make it a polynomial or something where you can just split it and rewrite it, you're good to go. Okay? You're good to go. Okay, so let's go to question number 7. So this one's weird. This one is weird for students to quite understand, but hear me out. Sometimes you guys will see questions, like I said, this was on the AB exam. It says, let f and g be differentiable functions with the following properties. So we know that g's got to be positive. That's what this says, that the function g is positive for all values of x. And we know that f of 0 is equal to 1. Okay, we know f of 0 is equal to 1. So it's telling you that if h of x is this composition, this, no, not composition, a product of f of x times g of x, and it's telling us what our derivative is. It's telling us this, what is f of x got to be? Or what could it be? So the first thing we're going to do is, when you're seeing this right here, you realize that this doesn't make a lot of sense because we have to use the product rule. So if we go and do it correctly, and this is correct, you guys will see what's going to happen in this problem in a second. For this particular example, this is the correct derivative, and you guys will see why in here in a minute. But we're going to use the product rule. So we're going to use the product rule for this problem. Because again, we're given a function where we have a product of 2 functions. So we're going to go first times the derivative of the second plus the second times the derivative of the first. Okay, so this is the true derivative of h prime, or of h of x. Well, this is saying to us that the derivative is actually f of x g prime of x. It's saying it's this. So what this means, ladies and gentlemen, is that this has to equal 0. right? This has to be equal to 0. If this does equal 0, if g of x is 0 or f prime of x is equal to 0, then that means that the true derivative would just be this first term, right? So it's also telling us that g of x must be greater than 0, which means that this is not 0. So that's why this term is there. That's why they're telling you this, that this is greater than 0. So that's telling us that f prime of x has to be equal to 0, right? F prime of x must be equal to 0. So it's asking us to find what f of x is. Now, technically, you should know now that if what function's derivative is actually 0. What function's derivative is 0? And that answer is a constant, right? If f of x is equal to some number, c, then the derivative has to be 0. So of all of these choices right here, the only choice that it can be is 1, right? It's going to be 1. And you also know that it's defined because it's given you that g of 0 is equal to 1. So you know that there's a function in this particular example. Okay, so hopefully that makes sense to everyone, and we're good to go. All right, last example, you got it? Here we go, and then we're going to get to a video for the chain rule, super important one. So let's look at this problem. It says the equation of the tangent line to the graph at the point 1, 5. Now this one's a little bit mean because you have to, first of all, get it point slope form and then make it and go into standard. So it's a little bit of work. I don't imagine, this is not an ideal problem for us to do, but it is what it is. The rise in the notes because lots of reasons. One, you can't split it up like we did in number 6. You actually have to use the quotient rule. And so let's do that. And then I'm going to show you guys my biggest strategy, why I'm showing you guys this problem and why we have it in the notes. So y prime. So again, we're going to go do quotient rule. So this is the quotient rule problem, right? So this is our quotient rule. And we have to use it. We can't split that up. So it's going to be the denominator or our low, parentheses, parentheses, parentheses. If you do not put parentheses around this, and this is just an FRQ question, you've lost the whole point. Every single thing. They do not tolerate, unfortunately, in calculus, A, B, or B, C, they do not tolerate bad notation. So if you do not put parentheses around that and you just do the derivative of the top, then they're going to take the points off. Okay, so just be careful with that. So denominator times the derivative of your numerator. So it's low d high, right? Minus, because it's the quotient rule. Good old girl Heidi low, right? High times the derivative of low all over low, low. So this is the derivative of our function right here. This is where I want to tell you guys, and this is really, really, really important, is right now plug in. There's no reason to simplify this. You know what x is. X is 1, and they're going to give you an example where it's a very easy number to plug in. Plug in immediately. So I want to know what y prime of 1 is. And I'm choosing 1, not 5, because these are x's, right? Students ask, well, why not the 5? Because that's a y coordinate, right? So we're going to find 1. So I'm going to plug in 1 here. So 3 times 1 is 3, minus 2 is 1. Well, that's obviously still 2, right? 2 times 1 is 1, plus 3 is 5. This is going to be 3 still. And then this is going to be awesome, and they always do this nice stuff for us, is that this is going to be 3 times 1 is 3, sorry, 3 times 1 is 3, minus 2 is 1, 1 squared is 1. So it's just going to be this, and that's going to be equal to 2 minus 15, which is going to give you negative 13. So this is going to be your equation in point slope. All right, now we haven't solved the question yet, but we're getting there, right? We're getting there. So hopefully that makes sense. With the whole point of this problem is you have to use the quotient rule. You have to know it. Low d high, remember d again for derivative, low d high minus high d low over low low, and then immediately plug in. You don't need to distribute the 2 and the 3 and then simplify like terms. Plug in, plug in, plug in. If you know what x is, you know what y is, plug in, plug in, plug in, plug in. All right. So I went ahead and erased this because now we got to find our answer. So it's going to be y minus 5, and this is an algebra 1 problem, maybe? I don't know. So y minus 5 equals negative 13x plus 13. And we're going to get this in standard form, right? Notice these are all in standard form, so the x's and the y's are on one side. So I'm going to move the 13 over here. And I got the y, and I'm going to move the 5 over here, and I'm going to get 18. So if we look at our choices, this should yep, it's B. The answer is B. All right? So I always just like to look at the rest of them to make sure they're all good. and we're good to go. As a matter of fact, it's really interesting. Let's say you guys are running out of time, and you guys get to this and like, all right, you have 30 seconds left, and then you got to stop. Well, you clearly know that it's going to be negative 13x. You know that's going to be part of the answer, right? Because you're multiplying that. So you can eliminate C, D, and E. Well, you also want to make sure that nothing simplifies. I should clarify that. Well, this 13 is a prime number, so it can't simplify. So you know that you could already go to either A or B just by really quickly looking at that. All right, so we're good to go. We'll see you guys in the next video when I do the good old fun chain rule that's really, 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 really important.